Okay, well, starting today's stream a little bit early, just so that I can show a little bit of the plugin that I've installed. So I installed a yesterday I mentioned I installed a snippets plugin, which means I've added a bunch of um, shortcuts. Basically, if I go sum and tab, I basically immediately get this sort of thing coming out. It just means I get that straight away because it's such a repetitive amount of code. Really cool thing about this plugin is you can set it up so that it automatically highlights this, and I can type in, for example, over data, I hit tab, I can rename this variable to something else, like that, in case there's any collisions or anything. So hopefully that'll help me get some stuff put together a little bit quicker. I did realize yesterday I didn't put together a oh, I already have this file open. I didn't put together a snippet for map, so I'm just gonna try and put that together right now before the challenge starts. Map is a little tricky. It should be okay though. So map. I actually do want to flip some of these around, but we'll do that later. I wonder how I want to do this. Probably want that second, that one third. We do want that append, but we probably want like v2 equals some sort of function on v, and we append v2. And if I save that, I think, ooh, okay, never mind. I can't use map because there's already another snippet called map. So we'll call this, we can't really call anything else. Just rename it to MP. So map data, call it out. I forgot to put in a thing for type. So type, so this is 4. Oh, anyway, it looks like it's about to start, so let's hope that I don't need that, because it feels a little bit raw, but let's see how it goes. We're going to start today's challenge. Oh, by the way, if you're watching, there's no live stream tomorrow because I am unfortunately busy at this time. So that's just something to be aware of. Other than that, let's get started. Day 7, 7-segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of the 7 segments named A through to G. A, B, C, D, E, F, G. Cool. So A, B, C, D, E, F, G. Oh, you can't see my mouse. Should be okay. To render a 1, only segments C and F would be turned on. The rest would be off. To render a 7, only segments A, C, F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each display. So, okay. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digits that use 2 segments is 1, so that means C and F must be on, and so on. For each display, you watch the changing signals for a while, make a note of all 10 unique signal patterns you see, then write down a single 4-digit output value. your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you might see. Make a note of all 10 unique. Okay, let's take a look. The entry is wrapped here to 2 lines so that it fits. In your notes, it will all be on 1 line. Let's just take a look at the input. So at the end, it's a 4-digit thing, right? Okay. Because digits 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values, the part after the... Oh, hang on, I skipped ahead. Here. Each entry consists of 10 unique signal patterns. 10 patterns. 1, 2, 3, 4, 5. Okay. A delimiter and a pipe, and then finally the 4-digit output value. Within an entry, the same wire segment connections are used, right, within the same line. Okay, using this information, you should be able to work out. For now, focus on the easy digits. Consider this larger example. Because 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values, the part after the pipe on each line, there are 26 instances of digits that use a unique number of segments. In the output values, how many times do digits 1, 4, 7, or 8 appear? Well, that's okay. So it looks like we do have to solve this puzzle eventually and work out what each line is. But for now, we just need to split each line. Okay, so that's not very useful, is it? That thing. So for each line, keep calling it v. String start split it on space pipe space, and then we split it again, split the second half again on space. Cool, and that should always be an array of size 4. Which we can check by doing this. We should just have a screen of 4s. Great. So for each of those, we want to count how many have exactly 2, 1, 2, 3, 4, 1, 2, 3, or 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, or 7. Okay. So we just have a count here. We're just going to count. Sorry, there's a lot of noise outside my window, so sorry about that. Let me close my other window as well. So for each digit in there, what do we want? We want to count if the length of it is 2, or it's 3, or it's 4, or it's 7. And I know I did that wrong. Then we increment the count. We print out the count at the end. 504. I think that's probably right, so we just plug it in. Cool, 618. That's not too bad. So I like how a lot of these puzzles, they kind of build up the challenge. So we start with something that's a bit easy, and then now that we've identified, have a way of identifying which ones are the easy ones, we can start putting together an algorithm to work out what each number is. So through some deduction, you should be able to work it out. I'm going to skip ahead a little bit. The 4 digits of the output. So once you've worked it out, right, assuming we have a way of working it out, the 4 digits of the output can be decoded as this. Therefore, the output value of this entry is 5353. Following this process, for each entry, the output value of each entry can be determined. Adding all the output values together produces this number. For each entry, determine all of the Y segment connections and decode the 4-digit output values. What do you get if you add up all the output values? Okay. What's a nice way to do this? Let's see. So looking at this diagram here, if we know, based on the 2 and the 3, no, based on the 1, sorry, so the 1 which has 2 segments and the 7 which has 3 segments, we can work out what the top line is, right? So I'm going to call these A through to using the same notation that they have. So A is going to be the difference between 7, the 3 length one and the 2 length one, right? That's going to be the top one. Hey, Cyan, thanks for joining me. Cool. So we can work out. Okay, wait a second. Let's just put this together first. So 0 has 1, 2, 3, 4, 5, 6 segments. 1 has 2 segments. 2 has 5. 3 has 5. 4 has 4. 5 has 5. So 2, 3, and 5 are the hard ones. 6 has 6. 7 has 3. 8 has 7. And 9 has 1, 2, 3, 4, 5, 6 segments. Cool. So 6 segments are 0 and 6 and 9. Right. Okay. This is going to be helpful. So we know that B and D are going to be the diff of the length 4 one. Okay, you know what? Diff of 4 and yeah, we'll call it length 4 and length of 2. And the same for D. So what's the difference between 9 and 6? Right. So 6. 6 is going to be the 1. So C is going to be the one that is in length 2 and only in, oh wait, that might not be right. Yes, and only in 2 of length 6. It's going to be C. D is going to be the same thing that we can do there. In length 4 is not C, is in length 4 and only in 2 of length 6. Which means it's that and not D. E. Okay, so we have E, F, G left. Well, once you know what C and D are, then you know what E is, because it's the only one that is missing. Yeah, missing from length 6 and not C, not D. I think this is good. Then F and G, F is the one that's only missing in one of them. And then G is the one that's left. So what's the nicest way to put this together? I think we just need a short algorithm to put these in. We've got our 10 digits. So we deduce. We need digits, which is going to be a list of strings. Those are the segments. Okay. So we want to pull them out by yeah, we'll call them like this: len 2, len 3, len 4, len 5, len 7. I wonder if they use the same order. It's not in the same order. Okay. That's a little bit annoying to do matching. Okay. Let's just do this. We'll just walk through this step by step and not try to take too many steps in one go, because that was what I did wrong last time, and I ended up flailing around quite a bit. If len v equals 2, len 2 equals v. Else if len v equals 3, len 3 equals v. Else if len v equals 4, len 4 equals v. Else if len v equals 7, len 7 equals v. Else we have len 5 and len 6 left. Now what I'm going to do is I'm going to have a normalize function. And all I'm going to do here is sort it, put it into order. Lots of ways to do this, but we'll do it like this, I think. I hope that works. If sip is empty, split splits after each UTF-8 sequence. Good. Yeah, so that's just going to give me, yeah, normalize all the digits. So let's do that. Normalize. Okay. else. We're just going to call them 5a, 5b, 5c, 6a, 6b, 6c. That doesn't sound a very good way to do it, does it? We'll do this. And the last else is just if it's 6. Cool. Cool. So I have all the digits. The important thing is about identifying what each number is, right? So what we really want is just, what we return here is an array of size 10. And we just need to say what each one is. So 0 is unknown. 1 is going to be len2. 3 is going to be, no, 2 is going to be unknown. 3 is unknown. 4 is going to be len4. 5 is unknown. 6 is unknown. 7 is len3. 8 is len7. And 9 is unknown. So all we're trying to do here is, actually this is the wrong way around, because we want to be able to index the numbers. Yeah, this is the wrong way around. So we actually want map string to int. And we want to say len2 is 1, len4 is 4, len3 is 7, and len7 is 8. Cool. So how do I, so the question now is, how do we differentiate between 2, 3, and 5? Or how do we differentiate between 0, 6, and 9? That's what we want to do. So to differentiate between 0, 6, and 9, we look for the one that doesn't have one of the numbers, one of the letters in number 1. So find 6. Missing a letter from 1. So for each letter in 1, maybe we should keep these as it'd be easier if these were sets. I guess we could index of. Yeah, let's index of. Yeah, we can index. And what does index return? Why is there no documentation for it? Why is there no documentation? Okay. Index returns the index of the first instance of substring or -1 if it's not present. Okay. So for each digit in len 6, strings.index of d, and we want len2 0. If this is -1, because every 6 length digit has f in it, and only one of them is missing a c. So this will only return the case when c is missing, which means it's 6. If we've done this, then out d is going to be 6, and we can break. So we've found 6. So that would find a 6. Now, do we want to get rid of 6 from we don't actually have to. And now we should. I hope this doesn't break. I'm just going to delete 6 from the array. 0 to I. And then because we break, it should be okay. Now, I do think that might break, because if I was the last digit, I don't think you can index that, but here's an example. Oh no, that does work. Wow, you can index past the end of the array. No, you can't, but you can do the final element. Oh, that's great. Okay, so that should work. So that deletes 6 from the array. Now we can do the same thing to find 0 and 9. How do we differentiate between 0 and 9? Well, the easiest way is to do the exact same thing, but to do it with 4. Because now, whichever one is left, whichever one is missing a value from 4 is going to be the 0. So with whatever's remaining, this time we do it to all the digits in 4, all the sequence in 4. This is going to be 0. And the remaining one's going to be 9. which leaves us with the fives, the length fives. 2, 3, and 5. How do we differentiate between those? The one that has all the ones from 1 is going to be 3. Right? Yep, the one that has everything from 1 is going to be 3. So find 3 now. That contains all of 1. So with all ones in 5, if index is not -1 and index of the second digit is also not 1, then we have found 3. Now D is 3. And this is then 5 now. So now we only have to differentiate between 2 and 5. What's the easiest way to differentiate between 2 and 5? Whichever one can be found in all of 6 is going to be 5. That's one way to do it. Is all in 6. So for each one, this is going to be a big conditional, but if index of, now this is the other way around, isn't it? Now we need to know what 6 is. So we just need to have a thing here, find 6. So var digit 6. String just to get that out there. So this time we're looking for digit 6, and if D0 is in 6 and D1 is in 6 all the way through to D4, because there's 5 things in there, then we have found 5. And we have 3 remaining. No, we have 2 remaining. Yeah, we have 2 remaining. So out len50 is 2. Return out. This is going to be epic. So we're only going to do this for the first one for now. Let's see. We're going to deduce strings.split v2 0. And we're going to print that out. And we're going to break here. Okay, let's see if this is correct based on the first one. AC is 1. We have 1, 0, 1, 2, 3, 4, 5. It's kind of hard to tell if it's right, but I feel like it's right. I need the chart. I'm gonna, okay, hang on. So we have AC for 1. So maybe this one's A. How do we know which one's A? Whichever one's in 2. 2 is A, B. Okay, so since 2 shouldn't, well, whatever is in 1 and is in 2 is A. So apparently this is A, not this one, which means this is C, supposedly, based on our deduction. 7 is up here, so this is E. 4, D and G are these two. D, whichever one is in 2 is the one that's in the middle. So this is D, which means this is G. Now E is in 5. What's in 5? We have B and C, D, E, F. B and F left, and F is in 3. So this is F, and F should also be in 5, but not B. Yes. Whoops. So this should be B. So we can check this by going, say, 6, which we haven't checked yet. 6 turns on B and C. F, it turns on everything except A, is 6. So that looks pretty good to me. That looks pretty good to me. So this is digits. It's going to be this. So then what we do is for every value in V3, right? So digits V3 0 times 1000 plus digits V3 1 times 100 plus digits V3 2 times 10 plus digits V3 3 should be our 4-digit output number. Made a mistake somewhere. Oh, whoops. Can't print that. Oh, this is not a string. So this is going to look a little bit ugly. Sorry about that. Whoops. And no, I actually had that right. These strings should actually be the normalize function, which I knew I put in there for a reason. 8, 5, 2, 8. That looks reasonable. We're just going to print out 10 of these. 9, 6, 6, 8 looks reasonable. 1, 7, 4, 4 is very reasonable. 1, 7, 6, 1 could be reasonable. So that looks decent. Number 10 is 8, 8, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, so this should be 0. It's a 6-digit number. Okay, I'm happy with that. So I have all my numbers. What I have to do, I have to add them all up. So let's sum them up. What is that? Sum plus equals output. And we print line count and sum. And we don't want this break because that will go very wrong. Get rid of an unused variable, and there's my number. Okay, so 1073431 gives us the answer. 700. Oh, that's pretty cool considering how long this took. Um, yeah, wow, that's a really cool puzzle. So you see, because this sort of challenge, right? If you did it on pen and paper, it's not too hard. You can sit down and work out what each segment refers to, and then figure out which one is which digit, right? But to kind of turn a logical solution into code can be quite tricky because you need the right data structures, right? In my case, I am totally not using the right data structures. Go. What would be nice is if we could use sets, uh, but Go doesn't have built-in sets. Thanks, Sam. I'm really happy. Thanks for being yeah. Thanks for cheering me on. Go doesn't have sets. Go has a makeshift set which looks like this. Um, and then what you can do is you can use map semantics. It's a map, but it maps to an empty struct, which takes up no space in memory. And so this is kind of like a makeshift set in Go. And the syntax for it is you would go this. This would be a test for if your item belongs in the set, and this would be your syntax for if an item does not belong in the set. I could have done that, but I decided to just stick with string types because, as usual, when you want to go for a simple, straightforward, naive solution, strings usually works pretty well. And if it's not algorithmically intense, strings compute okay. Again, clearly not the most efficient solution. I think, yeah, coming up with, I think the key to this was, yeah, coming up with your solution for how you would distinguish between the different numbers, and then just coding that up, working through them all based on what you have. Not the cleanest code, a lot of copy pasting. You could turn this into a loop, for example. If you had access to like sets, maybe you could actually do set diffs. The other interesting thing with how I did this was, of course, I decided to map each sequence of letters to the number. Whereas what you could have also done was try and work out which segment each segment refers to. But I think trying to work out which segment each letter refers to is going to be harder to do. And then you have to do another mapping afterwards to say, okay, these segments equals this number, and so on. And especially since, yeah, I feel like that way you'd end up doing more work. And I guess just one final thing that I thought of about this specific solution, this normalize function, yes, it's very poor coding, but this came out to be really useful because, as you can see, like these two numbers are both eights, I'm pretty sure, because they're 7 digits long, but the order of the letters were scrambled. And if you had sets and you could do set equality, maybe that would be okay. In my case, because I was using, I didn't have set equality and I was using just strings in a map, normalizing them beforehand really turned out to be really useful. Yeah, so it's been a long stream. It's a really cool puzzle. I liked it. I really enjoyed it. It was a little bit frustrating to put together a solution for, but yeah, when you have a solution, it's actually pretty cool. I liked it. So thanks for joining me today. I hope you have fun with the problem as well. And I will see you again. Actually, no, I won't see you tomorrow because, like I was saying before at the start of the stream, tomorrow I am unfortunately busy at this time, so there is not going to be a live stream. Although I will do it and will post up a video afterwards, it won't be at this usual time slot. So I will see you again in 2 days. Have a good morning, evening, wherever you are in the world.